Now, let's look at one-sided limit. So, whenever you are approaching a particular value, like for instance, normally we say x approaches a value, the limit of, for example, f of x as x approaches some e. Now, if this is e and x is a value that is approaching e, x approaches e from this side or x approaches e from this side. The previous problem we've been doing is in the general form. So when x is approaching e from this side, it means that x is approaching e from the left. When x is approaching e, when a particular value is approaching e, it means it's approaching e from the right. So that's the difference between the right-hand limit and the left-hand limit. So we say if the limit of f of x as x approaches a from the left, let's say from the right, this symbol indicates this a left, a right. This means a particular value is approaching a from the right. This is a from the right. This is a from the left. So we say if the limit of f of x as x approaches a from the right is equals to L, we have a right-hand limit. So this is called the right-hand limit. And when the limit of f of x as x approaches e from the left, this thing means from the left, is equals to L, we have the left-hand limit. Now, so whenever you have a left-hand limit and a right-hand limit, then you always test for the existence of the limit as whether the limit does exist. Now, for the limit to exist now, the left-hand limit and the right-hand limit must be equal. Meaning, if you take the limit of a function from the left and you take the limit of the function from the right, they must be the same. For example, if x is approaching a, let's assume this a was a number 2. When a particular value is approaching 2 from the left, it means it is very close to 2, assuming 1.99. If a particular value is also approaching 2 from the right-hand side of 2, it means it could possibly be 1.001. Now, if you look at this thing, 1.99 and 1.001 approximately is also 2. So the limit of the right hand and the left hand must be the same for a limit to exist. So we said the limit of f of x as x approaches a from the right, when it is equal to the limit of a function as x approaches a from the left, or equals to one value L, we say that the limit exists and it is equal to some L. When it happens on the opposite, that is to say, when the limit of f of x as x approaches a from the right is not equal to the limit of a function as x approaches a from the left, we say the limit does not exist. So before we go to some examples, let's look at quickly the piecewise function, because most of the functions that we'll be dealing with, most of the examples, we will construct them in piecewise function. A piecewise general function is defined as a function that is being represented by more than one expression or more than one function. There's a function called f of x. So this f of x, you have a constant function, meaning a function that comprises of only number, and you have a linear function, a function where in the highest variable is 1. So this function f of x comprises of two distinct functions. So sometimes a piecewise function can comprise of 2 functions, 3 functions, 4 functions, and so forth. So let's look at the first example. The example says that we must find each limit if they exist. Get in mind, when does a limit exist? We said a limit does exist when the limit of a particular function as x approaches a value from the left is equal to the limit of a particular function, meaning the same function, as x approaches that same value but from the right hand side. So let's look at this. F of x is equals to piecewise function, which is 5, if x is greater than 2 and x plus 2 when x is less than 2. This is 2. When x is greater than 2, it means you are referring to numbers in this direction, in this direction, right? That is to say, all these numbers are greater than 2. It means x, which take on those numbers, is approaching 2 from the right hand side. So we call this greater than right hand side limit. We call greater than or equal to right hand side limit. Now I only indicated this, but you won't see this in many problems. In fact, in no problem you will see where it will indicate right hand or left hand. I'm just telling you that whenever you see greater than, you must think of right hand limit. When you see greater than or equal to, think of right hand limit. Likewise, when you say less than or less than equal to, think of left hand limit. Because when it is less than a particular value, it means it is approaching that value from the left. So since we have two functions, we take the limit of each of those functions. The limit of 5. As x approaches, we have 2, right? So since there is a right hand limit, we say x approaches 2 from the right. Right? Equals, then we put a question mark right here. The limit of x plus 2 as x approaches 2 from the left. So the limit of a constant is just equal to a constant. Put a question mark because we don't know as well they are equal. This one is 2 now. We put 2 plus 2. So this is 5 is not equal to 4. So we conclude that the limit does not exist. Now, so we solve example 2. Example 2 says f of x is equals to the piecewise function x plus 3, x is less than 7, 2x minus 4 when x is greater than or equals to 7. So this side represents left hand and this side represents the right. Because this is less than, this is greater than. So we take the limit of each of those functions, x plus 3, as x approaches the number 7 from the left, must be equal to, so put a question mark, the limit of 2x minus 4 as x approaches again 7 from the right. So in some cases, we can solve them separately and compare their results as to whether they are the same. So then we'll just take this thing from here like this and we will solve them separately. And at the end of the day, we'll just compare the results. If the results are the same, then we say they are, let's say the limit does exist. If they are not the same, we say the limit does not exist. So let's do this one in this form, and then the next one will continue from how we've been doing it. So we take the limit of this function now. When x is now approaching 7, we replace this with 7. 7 plus 3. This is now 10. We have 2 times 7 minus 4. 2 times 7 is 14. Minus 4 is 10. Now because the limit, so we say since the limit of x plus 3 as x approaches 7 from the left is equal to the limit 2x plus or 2x minus 4 as x approaches 7 from the right since the limit of this function is equal to the limit of this function, or equals to 10, we say that the limit does exist. So the limit does exist because both value give us 10. Question number 3 says the function f of x is equals to x minus k all raised to the second power minus 3. Now x is less than 0. It means this is the left hand. X plus 2k, x is greater than 0. This side is the right hand limit. So the left hand limit and the right hand limit, when they are equal, we refer to the function to be a function that does exist. So now we have the limit of the first one. You have the limit of x minus k all squared minus 3 as x approaches 0 from the left equals, we put a question mark, the limit of x plus 2k as x approaches 0 from the right. So now we do not need a question mark because we have a variable right here, right? We have a variable, just look there. So we apply the limit now, you have 0 minus k is equals, that's a minus 3 now. This all square equals, so we don't need a question mark because we already have a variable within this problem. So we have 0 now plus 2k. Now someone may ask, but we have two variables. Now the first, this first variable, right, it represents the variable within the function that x is approaching, right? Let's say that is representing x. But this other variable is a constant. It's representing a particular value. But since we do not know that constant, so until that constant is known, we cannot tell as to whether the left hand side is equal to the right hand side or whether the limit does exist. So based upon that, we will be finding the constant. So we don't need question mark because we will still be finding the constant. So now this is minus k times minus k because this what is in there must be multiplied twice. This is already 0. So this gives us positive k squared. Minus 3 equals to 2k. So this is a quadratic equation. So quadratic equation, we must first ensure that one side of the quadratic equation is in the form of as squared plus bx plus c, and the other side is 0. So this is now the k squared now, which is representing x squared, minus this 2k, we send it across, it becomes minus 2k. Then we have minus 3, which is a constant. The right hand side is equal to 0. So we can factor out now, right? All equals to 0. K times k give us k squared. Which two numbers can we multiply to give us minus 3? When we add them, we get minus 2. So if we have minus 3 times positive 1, it's equals to minus 3. Minus 3 plus 1 is minus 2. Now at this point, we want to solve for k. We take each factor, x minus 3 equals to 0, or x plus 1 equals to 0, using the 0 property. So k now is equal to, if this is k, this is not x. K is equals to positive 3 because we send this 3 across, and this side k is equals to minus 1. So let's test. So take the first one at k equals to positive 3. We want to know as well the limit does exist. So if you look here, this side must be equal to the other side, right? If this side is equal to this side, it means it does exist. So k squared minus 3 must be equals to 2k. So k now is 3, so it's 3 squared minus 3 equals to 2 times 3. This is 9 minus 3. This is 6. So in this case, now we can put question mark. So this 6 equals to 6. We take the next one. At k equals to minus 1. So we have k squared minus 3 equals to 2k. So this is now 1 minus 1 times minus 1, which is minus 1 all squared, equals to 2 times minus 1. So what happens? Minus 1 times minus 1 is positive 1. Minus 3. So this is minus 2. 1 minus 3 now is minus 2 equals to minus 2. So here we can put question mark here, and at the end of this, we just maintain it as it is. So minus 2 equals to minus 2. 6 is equal to 6. Therefore, we conclude that the limit does exist. Limit does exist. Now let's do question 4. Question 4 says, find the value of k for which the given limit exists. So we know that the limit will exist. When we take the limit of the left and the right hand, it will exist. But we must find that value of k that makes the limit to exist. So we have the left hand limit. Now remember we told you when it is less than, it's left hand. So this function represents the left hand limit. Minus 3k as x approaches what? 2 from the left is equal to the limit 4k plus 2x as x approaches 2 from the right. Now we don't have to put a question mark here because the question says find the value of k for which the given limit exists. So it means the limit exists. We need to find the value of k. So we put in the value for 2 here. You have 2 minus 3 times k equals to 4k. 2 times 2 now is 4. So we solve for k. So we have 2. We can send this 4 across. It becomes minus 4. We send this 3k across. Is 4k minus, let's say plus 3k. So this will give us minus 2 now equals to 7k. We divide this out by 7 and this out by 7. So 7 cancels 7k now will be equals to negative 2 over 7. Or negative 2 over 7 is equals to k. That is simple. So now let's verify. So we take it from right here, right? From right here. Let's take it from here. So we have 2 now minus 3k equals to 4k plus 4. Now we know that k equals to negative 2 over 7. So we have 2 minus 3 times negative 2 over 7 equals to 4 times negative 2 over 7 plus 4. So it's 2 times negative is positive, 2 times 3 is 6 over 7. 4 times 2 is negative 8 over 7 plus 4. So we find our LCD for each of these, right? So this side now you have 7. 1 into 7 goes there. 7 times 2 now is 14. 7 into 7 is 1 times 6 is 6. LCD is 7. 7 into 7, 1 times minus 8 is minus 8. 1 into 7, 7 times 4 is 28. So 14 plus 6 is 20. And minus 8 plus 28 is also 20. So therefore it has been verified that k is the value for which the given limit does exist. Okay, now so let's solve question number 5. And then from there we're going to put some supplementary problems there for you to practice. So question 5 says, the function you have, the piecewise function 2x plus 1, 3x, 2x minus 1. Now you have three different functions. In the middle, you have a double inequality. Now, so what you can do is that since we also have two different numbers, like 1 and minus 1, it means we can open up this double inequality. So we can rewrite this thing as the function f of x now is 2x plus 1 if x is less than or equal to minus 1. Now this one now is 3x and then 3x. We read it twice, right? But in the first case now, remember if this is less than minus 1, it means the next thing you just want is greater than 1, right? So now look here. If minus 1 is less than x, it means x is greater than minus 1. So here will be x greater than minus 1. Then the Cx for this function is greater than, let's say is less than positive 1. And then the last function 2x minus 1, we have x now to be greater than or equals to positive 1. So this thing is being divided into 2. So we test the left and the right hand side. This is the left, this is the right. At the point minus 1, we test the left and the right at the point positive 1 as whether the limit does exist. So we take the first one, the limit of 2x plus 1 as x now approaches minus 1 from the left is equal, with a question mark, the limit of 3x as x approaches minus 1 from the right. So now this is minus 1, 2 times minus 1 plus 1, and this is 3 times minus 1. So we now have 2 times minus 1 now to give us minus 2 plus 1. We put a question mark here. And then this is minus 3. So minus 2 plus 1 minus 1 is not equal to minus 3. So the first one, it is not equal to minus 3, right? The left hand limit is not equal to the right hand limit. So it means the limit does not exist at x is equal to minus 1. Limit of the function does not exist at x equals to minus 1. So let's try the next one. We'll take this one. This is less than, so it means it's the left hand limit. This is greater than is the right hand limit. We have 3x, so we take the limit of 3x. X is now approaching positive 1 from the left, where the question mark, the limit, 2x minus 1, 2x minus 1, x approaches positive 1 from the right. So this is just 3 times 1 now. This is 2x, which is now 2 times 1 minus 1. So this 3 is not equal to 1, because this 2 minus 1 is 2. So we say the limit does not exist at x is equals to positive 1. Okay, now so these are all supplementary problems. So you have to practice them, because the more you practice, the more the math formulas, the math concepts get used to you. So the first problem says that we must find each limit if they exist from question 1 to question 4. So you know that when it is less than, that's the left-hand limit. When it is greater than, that's the right-hand limit. So find the limit of the limit of the function as x approaches 0 from the left, and then you take the limit of the function as x approaches 0 from the right. If the two of them are equal, it means that the function does exist. So do that for everything. The answers are all in red. The first one does not exist, does exist, and so forth.